Okay guys, so first things first, make sure that you are in your correct new seat. These seats will be where you will stay until the last grading period. So make sure you're in your correct new seat. Today we're going to take some time to review counting elements and counting how many of each elements are in a certain compound. And so we'll start with number one, which is H2SO4. And so remember, when you're counting elements, you're really just looking at subscripts. And so for number one, you look at our hydrogen, okay? There's going to be two hydrogens because there's a subscript of 2 behind the H. We look at sulfur, there's going to be one sulfur, right? Because when nothing's there, it's an understood 1. And then when we look at oxygen, you're going to have 4 because there's a subscript of 4. Number 2 is CaC2H3O2 2. And so a couple things to remember here, okay? First things first, we have 1 calcium, right? Because there's nothing after the calcium, and so what's an understood 1? And then we look at the C, H, and O. We have to remember that that 2 distributes out to the carbon, hydrogen, and the oxygen. And so it's going to be 2 times 2, right? So you're going to have 4 carbons. You're going to have 6 hydrogens, because 2 times 3. And then, once again, 4 oxygens, because 2 times 2 is 4. So don't forget, when you have a subscript outside of a set of parentheses, it distributes out to everything inside the parentheses, and you just multiply to figure out how many you actually have. Make sure to keep your warm-up sheet in the back of your binder. That way you can continue using it. If you have a new one, that's fine. If not, you are very welcome to continue using the same warm-up sheet you were using before the Christmas break. Okay, a couple needs to knows before we get started with today's lesson. Just a couple reminders. Remember, if you miss work or if you're absent, it is your responsibility to pick up the work you've missed. It's going to be in the colored folders by the door on the cart. You can also find your missed work in Canvas, and so you need to take it upon yourself to find that misworked. I'm not going to give it to you. It's up to you it's up to you to get that and to get that completed. Hall passes you guys will get later on in the week. Remember, you only get 1 hall pass per grading period, and so once you use that, it's gone. You can save that hall pass and turn it in at the end of the grading period for 10 bonus points on a major grade if you would like. You can only turn in up to 2 hall passes for bonus points, and so only get 1 per grading period, so use it wisely. We will continue doing the raffle for prizes, and so make sure that you are doing your warm-ups and doing all the good stuff that'll get you tickets to win that raffle for cool prizes from my prize box. Alright, so as we jump into our first topic after the winter break, we're going to talk about chemical reactions. And so we're going to jump right into our notes. It is going to be the packet you got on your way in, which is packet 1. We're going to cover just a few notes today, and then you're going to have some time to practice the steps for balancing equations. And so we'll look at just a couple notes real quick. So take out worksheet 1 and be ready to follow along as we go through this. And so our first definition underneath chemical reactions, remember our chemical reactions have 2 separate parts. They have the products and they have the reactants. If you remember right, the products are going to be on the right side of the arrow, and these are the substances that are formed during a chemical reaction. The reactants, on the other hand, are on the left side of the arrow. These are going to be the substances that you start with in a chemical reaction. Remember back to our first grading period, right? Law of conservation of mass must be satisfied, which means our products must equal our reactants. Now, some evidence or proof that a chemical reaction has actually occurred would be temperature change, whether it gets colder or gets hotter, color change, an odor, maybe something that changes in the smell, a gas is produced, this is generally in the form of bubbles, or a precipitate is formed from two liquids, meaning you mix two liquids together and a solid is actually formed. And so these are all great examples of showing us that a chemical reaction has actually occurred. Now, here are our steps to balancing equations. This is going to be the first step in a lot of problems later on down the road. So if you haven't really been paying attention, now is the time to go ahead and tune in. So our balancing equation steps, our first step, we're going to make a t-chart. It's easiest, that helps us divide the left side from the right side. Then we're going to make a list of all elements. I like to say this is like your grocery list. It lists out everything that you can expect to find in that chemical equation. Then you're going to take the list that you write on the left side and you're going to write the same exact list on the right side. Okay? Once you write that list on the right side, then you're going to go ahead and start to count. You're going to count how many of each element you have on each side. Then you're going to make the left side equal the right side by adding coefficients. Remember that you never, ever, ever change subscripts. You might want to go ahead and put a star next to that or in front of that. Okay? We never, ever change subscripts. The only thing we change when balancing a chemical equation are our coefficients. We are going to go ahead and jump to worksheet 2 to take a look at some examples of balancing equations. So go ahead and take out worksheet 2. The steps are going to be on the left side, and we're going to look at the first two examples that are already done for you at the top. Just pay attention as we go through it, and then we'll work the two at the bottom together. So let's go ahead and take a look at this example. N2 plus H2 yields NH3. So our first step says to make a t-chart. And so that's exactly what we're going to do. We're going to draw a line down the center, dividing the left and the right side, dividing our reactants from our products, and then draw a line underneath the actual equation to go ahead and make our t-chart. Our next step says to make a list of all elements. And so that's what we're going to do. On our left side, we have nitrogen and hydrogen. And then it says to write the same exact list on the other side. We're not going to change the order. We're not going to do anything like that. We're going to copy the same exact list onto the other side. Once we have our list on both sides, then we start to count. We use our subscripts to tell us how many we have of each. And so we have 2 nitrogens on the left side. We have 2 hydrogens on the left side. We also are going to count on the right side. We have 1 nitrogen, we have 3 hydrogens. Now, the goal is to make the left side equal the right side. If the left side equals the right side, then we have a balanced equation. And so in order to do this, we are going to add coefficients to help us balance the equation out. Now, a little trick, whenever you're looking at an equation with hydrogen, a lot of times if you go ahead and balance the hydrogen first, it makes it a little easier. And so what I'm going to want to do here is I have 2 hydrogens on the left side, and I have 3 hydrogens on the right side. And so the only thing that I can do to make the left side equal the right side when it comes to hydrogens is to multiply 2 times 3 to get 6. And so that's what I'm going to do here. On the right side, I'm going to go ahead and add a 2. And so now when I multiply the 2 times the hydrogen, which is our 3, I now have 6 hydrogens. Now, that doesn't get me exactly equal because I still have to add coefficients on the left side. Now, when we added that 2, the number of nitrogens also changed. We now have 2 nitrogens. Notice that that made our nitrogens equal, so our nitrogens are now happy. The only thing is our hydrogens still aren't equal. And so to get our hydrogens equal, I need to have 6 hydrogen on the left side. So I'll go ahead and put a coefficient of 3 in front of the hydrogen, which means the hydrogen on the left no longer has 2, it now has 6. So if we look, 2 equals 2, 6 equals 6, and we are happy because our left side equals our right side. Just to kind of backtrack through what we did here. We started out without any coefficients. We had 2 nitrogens on the left, we had 1 on the right, 2 hydrogens on the left, 3 on the right. We start with our hydrogens to balance it, and so we have 3 on one side, 2 on the other, so we multiply 3 times 2. That tells us we need 6 on each side, so we put a coefficient of 2 because 2 times 3 is 6. And then on this side, we're going to put a coefficient of 3 because 3 times 2 is 6. That makes our hydrogens equal, and in the process of balancing those hydrogens, we also balance out our nitrogen because when we put the 2 in front of the NH3, we now have 2 nitrogens, and so that's going to be equal. The whole goal here is to make the left side equal the right by adding in coefficients in front of the elements or compounds. Now, here we have another example. This example is Cu2O plus C yields Cu plus CO2. And so for this example, we're going to follow those same exact steps. We're going to start by making a T-chart. This is to divide the left side from the right side and just give us a clear division between the two. The second step, we're going to make a list of all of our elements. And so we're going to start with the first element, which is Cu, or copper. We then have oxygen, and then we have carbon. The third step says write the same list on the other side. And so I'm going to take the same list from the left side and I'm going to write that over on the right side. Notice that even though the carbon and oxygen have switched places on the right side of my equation, I still keep them in the same order on the left side as I do the right side. This will help later on to make sure that I have the same exact number of each element on the left side as the right side. And so our next step, we start counting. We have 2 copper, we have 1 oxygen, and we have 1 carbon. We also count the right side up. We have 1 copper, we have 2 oxygens, pay close attention there, right? And then we have 1 carbon. So we start comparing. Our coppers are off, our oxygens are off, but our carbons are already balanced. And so the first thing I need to do, I need to have 2 coppers on the right side because I have 2 coppers on the left side, right? Everybody see this? We have 2 over here. We need to have 2 over here because I only have 1. Remember, the only thing I can do is add numbers in front of the elements, right? And multiply to get me where I need to be. And so the way we do that is we add a coefficient of 2 in front of the copper. So now we have 2 coppers on the right, so our coppers are going to be equal. Now, our coppers are equal, but our oxygen are still not equal. And so in order to balance our oxygens out, we're going to have to add a 2 in front of the Cu2O on the left side. Now we have 2 oxygens on the left side. But notice that our number of coppers have changed. We now have 2 times 2, which is 4 coppers. So, is the left side equal to the right side? No, right now it's not, because we have 4 coppers on the left and only 2 coppers on the right. And so you have to be careful throughout this process. Sometimes when you balance one side, it'll unbalance the other side. Notice that we had fixed our 2's, right? But now we have 4. And so not a big deal. All you have to do is go back and change that 2 on the right side to a 4. And when we change it to 4, we now have 4 coppers. And so we can check 4 equals 4, 2 equals 2, and 1 equals 1. Left side equals the right side. That means this equation is balanced. In order for an equation to follow the law of conservation of mass, and in order to see if it is written correctly, we have to make sure the equation is balanced. If the left side does not equal the right side, that means the equation is not balanced and it needs to be balanced. And so just to kind of step back through, once again, what we did here, we followed our steps by first making a T-chart. Then we list each element, copper, oxygen, carbon. We take that same list, we write it on the right side. Then we count the left side and the right side. We add coefficients in front of the elements or compounds to make the left side equal the right side. Remember, never change subscripts, only add coefficients. Okay, so now we're going to continue on worksheet 2. So work these two with me. Number 1, we have magnesium plus oxygen yields magnesium oxide. And so our first step, we're going to go ahead and make our T-chart. Then we're going to list our elements out. We have magnesium, we have oxygen. We'll take that same list and we're going to write it on the other side, magnesium and oxygen. Then we count. We have 1 magnesium, we have 2 oxygens. On the right side, we have 1 magnesium, we have 1 oxygen. Our magnesiums are equal 1 to 1. Our oxygens are not. And so in order to make our oxygens equal, I have to put a 2 in front of MgO. That way I now have 2 oxygens. But when I put that 2, I also change my magnesiums to 2 on the right side. When I do that, my magnesiums on the left side are not equal, so I have to go back and change the one on the left side. I'll add a 2, which changes the magnesium to 2. And so now magnesium on the left side is 2, on the right side it's 2. Oxygen on the left side is 2, and on the right side is 2. Those are now equal, and my equation is balanced. Number 2, I have P4O2, right? And then P2O3. And so I'm going to make my T-chart. I'm going to list my elements. I have phosphorus, I have oxygen. I'll copy it over to the other side, phosphorus and oxygen. I count, I have 4 phosphorus, I have 2 oxygens. On the right side, I have 2 phosphorus and 3 oxygens. Now, when I take a look at this, the phosphorus are unequal. And so in order to make them equal, I have 4 on the left side, 2 on the right side. I have to put a 2 in front of P2O3. Now I have 4 phosphorus. When I multiply 2 times 3, I now have 6 oxygens. So my phosphorus are equal, but my oxygen are not equal. And so in order to fix that, I have to put a 3 in front of the oxygen on the left side. Then I now have 6 oxygen on the left, equaling the 6 on the right. Now this equation is balanced. Technically, if you wanted to, you could put a 1 in front of the P4 because we only have one of those, but leaving it blank is also a sufficient answer. For the rest of the class period, you are to work on worksheet 3. Worksheet 3 is a fairly simple practice of balancing equations. If you're not quite certain how to complete the balancing, go ahead and look at the top with the instructions. There's a list of instructions and there's some examples on there to help you. And so go ahead and give it a try. You have the remainder of the class period to work on worksheet 3. We will do some more practice with balancing equations tomorrow. I will say this, it is extremely important that you get this balancing equation stuff now because this is the first step in every problem we do in our next unit. So if you don't get this now, then you won't be able to do the problems in the next unit. And so make sure you're giving this a try. And once again, if you don't quite remember, look back in your notes that we just took. And then also on worksheet 3, there are some instructions there as well. This will be checked in your first binder check on Friday of this week. You will also have a quiz on Friday that will cover everything we've covered this week, which is going to be balancing equations and the notes we'll take later on in the week. And so make sure you get worksheet 3 done now. So make sure you do worksheet 3 now because it will be checked on Friday's binder check. Once you're finished, make sure you put it in your binder. And you want to also make sure you put your notes in so that you don't misplace them because we're going to continue to use those for this entire unit.